If Bob Edwards was alive today, he would be 94 years old. Unfortunately, we lost him 6 years ago. I'm very grateful to the organisers and the other members of his team for inviting me to give you a snapshot of his life as the father of IVF. And I do that from 40 years of knowledge of him and now as his biographer. He was one of the most extraordinary men I ever knew. Energetic, brilliant, industrious, and sometimes mischievous. He was also somebody who was very self-reliant, and he had great inner confidence. And I think that can be summarized in a clip from a poem by Emerson called Self-Reliance. When I am entombed in my place, let it be remembered of a single man that he never, though he dearly loved his race, for fear of human eyes, swerved from his plan. Now, especially for those people who never knew Bob, I'm going to introduce him. If the slide moves forward. Move back.
I don't know who gave me this title. I can't see the future. It takes me all the time to see the end of the week, let alone the future of IVF. But at least I'll do my best. Now, the purpose of IVF was not only to alleviate infertility. It never was.
It's almost like a ghost in the auditorium here to hear his voice again after 20 years. But you know, he wasn't the first person to think of IVF. And in fact, it's rather like turning back our geological, paleontological history 200 million years to when our ancestors were oviparous, shedding our gametes into the environment. Not an original idea, but it was one that was going to be difficult. And the first people to try it in mammals were these people, Gregory Pincus and Miriam Mencken. And when Pincus left Harvard, John Rock, the gynecologist, took up with Miriam to try to fertilize human eggs. And they collected about 800 eggs. There were about 3 that they called embryos, although now there's a lot of doubt cast over that, that they were maybe degenerating or parthenogenetic. But they did leave a great legacy, because from flushing out in vivo conceived embryos from tubes and uterus, from timed intercourse, which seems extraordinary in America, although this was the 1940s, they assembled a series of human development that became very important as a reference later for IVF. And the specimens are still at the Carnegie Institute of Washington. But it was another man in the group, when they had started to work on the pill, M.C. Chang, who's the next person in the story, because although he was helping them with the endocrinology of the pill, he was always more interested in embryology. And some years later, it was 1959, he published the first authenticated case of IVF in a mammal, which was rabbit, and he followed up with Yanagi-machi in the hamster not long afterwards. At that time, Bob was still growing up. We had no notions of this work going on across the Atlantic. He came from a working class home in the north of England. His father was a coal miner, and his mother worked in a cotton mill. And I'm sorry that people on that side of the room will see my back and won't see the pointer. It was extraordinary in those days for a working class boy to become even a doctor, let alone a scientist. But he was a bright boy. He went to the best school after the examinations. It was a state school. But when the war came, he was sent by his mother to a remote part of the Yorkshire Dales. This is the home he stayed in. You can see him sitting outside there for a whole year with his brother. And they had no schooling except for learning how to do farming. And he fell in love with farming and agriculture. And he wanted to be a farmer or something related to agriculture. But then after he went back to Manchester and finished his schooling and had a place at university, he was conscripted into the army, and he had a memorable time in the army, serving in Israel during a very difficult time, 1948, during the end of the disastrous British mandate. But when he came back, he went to Bangor University to study agriculture. After 2 years, he told his professors, and you have to imagine Bob telling his professors he was bored, he wanted to change. He switched to zoology under the reproductive biologist Bramble, F. Rogers Bramble, who was a very distinguished biologist and inspired Bob. But after a year there, he had to graduate. He had no money to extend, and he didn't have enough credits for an honours degree, so he couldn't go on to do a PhD. So he left, really feeling very depressed for a while, and he was carting bananas to earn a little bit of money in the Manchester docks. Then one day he thought, I'm going to write to Professor Waddington in Edinburgh, a famous embryologist, remembered today as the man who coined the term epigenetics. So he hand-wrote this, sent it off, and amazingly, Waddington accepted him. So he went to Edinburgh and studied in the Institute of Animal Genetics, did a diploma. He did so well, Waddington rewarded him with a PhD, and after that, with a postdoc fellowship. And it was an extraordinary time in his life when he published about 55 papers. Some of those papers were with his wife, Ruth Edwards, whom he met there. He was very intimidated by Ruth because he came from a working class background and she came from scientific aristocracy. Her father was a famous Cambridge mathematician and her grandfather was the physicist Lord Rutherford. But they did some amazing work together on superovulation in mice, which is still important today. They moved to Caltech for a year. It was like a rite of passage for a lot of European scientists to go to America for a while. And he was funded for working on a sperm vaccine for contraception. And he really didn't believe in it. And in fact, it's turned out to be true. We still don't have a contraceptive vaccine. And on the side, rather like Chang had, he was doing embryology. And he was doing some work with Ruth, which only recently came to light when we looked into the archives at Caltech, that he was culturing mouse embryos and trying to develop blastocysts into some sort of stem cells in vitro, we thought. It's difficult to know from the results. And here he is in the California desert with Ruth. They moved to London when they started a family, had 5 daughters, caused quite a lot of conversation for a couple who were trying to control the sex ratio in their experiments at one time in their life. And he was continuing the work on this vaccine, which he hated, and doing some embryological work on the side. He also had a year in Glasgow where he made a breakthrough with stem cells. I don't have time to tell you about that. And as Klaus was mentioning, he was collecting eggs from doctors around London to try IVM, with the aim of doing IVF for a number of purposes, not just to treat infertility. And there were only about 50, as he said, that he collected over a couple of years. And that work continued when he moved with Alan Parks, his mentor. He always chose the best mentors in the country, to Cambridge. And in Cambridge, he started to do some teaching, and just mentioned very briefly, he was a brilliant teacher. He inspired some really outstanding students to come and work with him. here, in the picture taken in 1968, Richard Gardner in the background, and here's Barry Bavister, with whom they collaborated to achieve the first authenticated human in vitro fertilization using Barry's medium from his experiments on the hamster. And it was about that year that he had a famous meeting with Patrick Steptoe in London. Now, Patrick had trained in Paris to do laparoscopy under Palmer. And when he went back to practice it in Britain, he was treated like a black sheep because most of the gynecological community there thought this was a very dangerous continental practice. And so he worked in the north of England as well. You know, he was shunned from London, where he really wanted to work and where he graduated. And the link with Steptoe was so vital because Bob had a problem to get human oocytes for research and treatment. It wasn't going to be good enough to do what he had been doing, which was to be using biopsies. He had to be able to recover oocytes from patients through some sort of minimal access surgery. And Patrick had the answer, which was laparoscopy in those days. Now, in 1968, they had all these obstacles to overcome. They didn't know much about the physiology and embryology in those days. They had to answer the question of how to stimulate these patients. These weren't like Patrick's other anovulatory patients. These were ovulatory patients mostly, and so they didn't know how that would work. Then there were questions about how to collect the eggs, when to collect them, preparing the medium, and growing them, preferably to the blastocyst stage, and then how to transfer embryos and whether luteal support was necessary. They were always stumped for money. The Medical Research Council turned them down, so they had to scrape money together, even from their own pockets, to support their research. Now, they weren't completely alone in this. We think of Edwards and Steptoe, IVF. There were many very important people who were helping them, particularly the women. Nearly 300 women volunteered for a technology that the press was saying was monstrous, and even many doctors were repudiating. So they kept their volunteerism rather private. Ruth Edwards, his wife, contributed more than we will ever know. Jean Purdy was his assistant. She didn't graduate in science. She was a nurse, but she was meticulous and she was smart, and she was a very important person in the team. And so was Muriel Harris and her team of nurses. She worked for Patrick Steptoe and knew all the ropes for the laparoscopy and was prepared to work at any time of the day or night. And lastly, Lillian Howell, who has only come to light very recently after her death. She contributed secretly about $500,000 to their research when they were skint. She was an American, Californian millionaire who gave money to many charities, particularly related to women. Now here's a picture posed, I think, of Jean and Bob in the lab at Kershaw's Cottage Hospital. They started their experiments in the Oldham General Hospital, then moved a couple of years later to this tiny cottage hospital. You'll see it in a moment. And the lab area was absolutely minute, and the equipment was actually no better than what I had in my high school experience. The benchtop centrifuge was, I think, identical. They had Bunsen burner, and I like this. They had a kitchen timer. So this is Kershaw's Hospital. It's now a hospice. And we've digitized a 16mm cine film to show you what it was like in the early 1970s in that lab, narrated by Patrick Steptoe, and you see all three of the key team members.
Of culture medium into which the spermatozoa are to be placed, is being prepared. First, a sterile petri dish is poured with sterile liquid paraffin. And several droplets of culture medium are placed beneath the surface on the base of the petri dish. Here the aspirator needle is being introduced into the abdomen.
This is Patrick.
Approaching the ovary. There is a good ovarian response to the gynocephalins. A bluish pink follicle about 1.5 centimeters in diameter is present, and the needle is pierced through an avascular area, and gentle suction extracts the follicular fluid.
The next one is Bob.
The appearance of pre-ovulatory oocytes is typical, for they are surrounded by a thick viscous mass of mucus containing diffuse layers of tubular cells. Classification of the oocyte enables the pre-ovulatory follicles to be identified, and most of them are found to be the largest follicles in the ovary. Non-ovulatory oocytes are surrounded by several layers of tightly adhering corona cells, and oocytes are considered achetic if there are no attendant corona cells.
So, first problem they solved with Barry Bavistow was the question of capacitation. They thought that would be a stop on their project. But in fact, it turned out not to be as big an obstacle as they imagined. The next problem was, of course, the composition of the culture medium, and we've heard this morning from speakers about the importance and the ongoing developments to improve culture medium. They had very little information to go on. They started using Ringer's solution, which is basically 4 salts plus sodium bicarbonate, the salt water replenishment that's used in a drip today. So you can imagine this was very crude, later turning to something much more complicated but not designed for embryos, Hams F10, and they added serum or albumin. In very early days they used bovine serum and bovine albumin. This was before the days of mad cow disease, by the way. They made the adjustments that they felt were necessary, and then the dish with the drop of medium under mineral oil was placed in this desiccated vessel. And the desiccator was an instrument for keeping laboratory chemicals dry. And because I didn't have a gassed incubator, they weren't available in those days, they gassed this with 5% oxygen and placed it in the incubator. It was very time-consuming. This is Patrick's team, and next to him is Muriel Harris. They started procedures with diagnostic laparoscopy and seminology, of course, and in the early years they were using Pergonal with or without Clomid, and in the last years switched to natural cycles when they weren't getting success. In the first cycles, they were collecting eggs using a needle connected to a catheter to a syringe, rather like Bob was using to suck out eggs for IVM in London and Cambridge. But it really didn't work well, so Bob and Jean, or one of them, designed a novel aspirator which worked much better. They submitted the invention to a journal, and the reviewers turned it down, saying they couldn't see the point of it. Bob and Patrick never submitted a patent for this or for anything else in their research, to my knowledge. This is Bob at the microscope inside the hood. Embryos would generally transfer on day 3. Occasionally, when they had blastocysts, it would be at day 5, mostly transcervical. He'd learned that by watching embryo transfer in cows, and he really felt that this was going to be much better for the patient. And it was a tricky procedure, though, and in those days, they were using a stiff urological catheter, and that may have contributed to the poor results in the early days. And later, after they moved to Bourne Hall, John Webster, with a local company, designed a much more flexible transfer catheter. And modifications of that are still used today, as far as I'm aware. So this is the timeline, 10 years from 1968. The first 2 years, they had amazing progress. They got to the stage of producing the first blastocysts, not really very many as a percentage, but nevertheless there. And also, they sacrificed all of those embryos to examine their morphology, and Bob would spread the chromosomes. Now, in those days, all you could do was to count the chromosomes to see whether they were aneuploid or polyploid. You couldn't tell any more than that, and the technique was fallible too. You could easily lose the chromosomes. So they moved then to Royton, the other lab just up the road, about 5 miles away, and their results plummeted. People find results can vary from time to time, and they never figured out why, and they picked up again afterwards. And they were getting lovely embryos and transferring them from 1971 in the month of December, and getting no pregnancies until 1975, and there was a pregnancy result, and Bob was out in the wilds of Yorkshire somewhere, and he had a telegram, and he rushed down to Oldham with this wonderful news, but it turned out a few weeks later that it was an ectopic pregnancy, and as a result of that, Patrick decided in future he would tie the tubes of all of his patients so this could not happen again. And it was also a very important point from the point of view of the critics later, who would then not be able to say that if they had a baby, that it was from an in vivo conception. They had tussles over luteal support, trying various formulas, trying dopamine antagonists to knock down prolactin, all sorts of things they tried. Until 1977, they decided, let's go for the atom bomb, the most difficult strategy, but one which had least interference with the woman's physiology, to go for natural cycles. And there was a huge demand on their time because of the timing of natural cycles, and using a rather crude hemagglutinin test called Hygonovis to detect the LH surge. And when that was detected, then Patrick would go in and collect the single egg about 32 hours later. But it was two of those that led to the first two babies, Louise Brown and Alistair MacDonald. Now, there was competition in the sense, it wasn't like some forms of competition, because some of these were serious competitors and others were not. Now, in Australia, there was Carl Wood and Ian Johnston, and they came in with the third IVF baby in the world, as I'm sure you know, in 1980, and they were a very well-organized team that followed on from the early progress that Bob and Patrick had made. This character here, Landrum B. Shettles, was better known for his famous book, How to Control the Sex of Your Baby, much discredited method. And he tried to achieve IVF for a couple called Mr. and Mrs. Del Zio in New York, and it led to a terrible scandal. He lost his job at Columbia University and joined a clinic further west which was trying to clone humans. So no more need to be said about his science. This is a more interesting case of Subhas Mukherjee in Calcutta, and about 5 months after Louise Brown was born, there was a report that there was an Indian IVF baby born by procedures that Mukherjee had developed on the basis of reading the literature, never coming to train anywhere. And this became very controversial, and the poor man was so depressed that he committed suicide 3 years later. And to be honest, I'm still not sure what he created, whether it was actually a natural conception or really an IVF conception. And then there's this man here, Douglas Beavis, who in 1974 declared at a meeting in London, oh, there are already 2 or 3 IVF babies in the world, but he wouldn't declare where. And he was hounded by the press, and he ended his career discredited. The 1970s, particularly the early years, were dangerous territory for IVF researchers. But in 1978, there was the glorious news, the birth of Louise Brown here, being held by Bob, this is Jean, and Patrick, born in this hospital in Oldham. Not a big teaching hospital in London, but in the north of England, where you don't expect big breakthroughs to happen. And it was a world news, and the Brown family had a second baby, also a single embryo transfer, at the first attempt. So to summarize their data, there were, over those 7 years of transfers, 282 patients and 495 laparoscopies. It was a huge amount of work. And over that time, there were only 5 clinical pregnancies out of 112 embryo transfers from 91 patients. And this is a breakdown. This is Louise Brown here, single embryo transfer. There were 78 single embryo transfers, 1 miscarriage. And later, they found that there were some early pregnancy losses as they got a more superior pregnancy test. And this one here was Alistair MacDonald. 2 embryos were transferred. And you can see there were only 2 cases where they transferred 5 embryos. Had they transferred more embryos earlier on, they might have had success earlier, but they felt that it was too risky. After Louise Brown, they expected the country to invest in the revolutionary new fertility treatment, but the National Health Service turned them down. So reluctantly, against their principles, they went into the private sector, and eventually, after some trouble, they found investors to buy this property, Bourne Hall, a Jacobean country house about 10 miles outside of Cambridge. Not an ideal place to set up an IVF clinic, especially if you saw it when they got to it. And had they chosen a new build, it might have been better from the point of view of efficiency in the long term, but they fell in love with it. But in the first year or two, they had to operate out of these porta cabins out the front for the surgery, for the embryology and chronology, and gradually moved into the old house as it was converted and a new block. But by 1981, very early, they were organizing a world conference. Here's the team on the front bench here. This is John Webster, and I think this is a young Simon Fischel. Is he nodding his head? Yes. And this was the first of several conferences, signaling that Bourne Hall was leading the world, and in fact it led the world in a number of cases for a number of years. But of course they were spreading around the world, particularly among his friends like Howard Jones and his wife Georgiana in Virginia, where he spent a few weeks doing IVM in the 1960s. And Jean Cohen, a Parisian gynecology friend of his, with whom he set up Eschery and produced the second IVF baby in France. It took some time for the honours to roll in. It was so controversial. But there were calls to Buckingham Palace. There were honorary degrees. Here's one with Patrick in Hull. There was the Lasker Prize, sometimes called the American Nobel Prize, where Bob is speaking with the DNA pioneer James Watson, who was very critical of Bob years earlier. And this is a picture I took in 2008, my last visit to Bob's home, of his various awards, and it's not even showing all of them, which were put together by his daughters because they were all over the house apparently, even under the bed. He wasn't a proud man. But I remember that meeting that there was a sort of hint of sadness in his voice as he showed us these one by one, because there was no Nobel Prize, and he'd been nominated for years. But in 2010, the award came. But unfortunately, he wasn't well enough to actually attend. So Martin Johnson at the back there gave his Nobel lecture, and Ruth accepted the prize from the king. Well, I've just told you one of Bob's 9 lives, and all these other lives would really deserve a lecture of their own. He did the first embryo stem cell extraction from rabbit embryos with his Glasgow colleagues in 1963, and 1968 with Richard Gardner, sexing rabbit blastocysts. And of course this led on to pre-implantation genetic testing, as we call it now. And I know that Alan Handyside is here, and all credit to him for that great achievement, which also helped the legislation to go through for IVF in the UK. Bob was a bioethicist, the very first with David Sharp in America to write a paper about the ethics of embryo research and replacement. He was a politician, not an armchair politician, but he was actually elected, and he offered himself for national government at one time. In fact, while I was in the lab, and we were very frightened that he might be elected and we would lose our mentor. He was a socialist and egalitarian throughout his life, by his own description. He was an editor. He founded the 3 journals of Eschery, Human Reproduction, Molecular Human Reproduction, Human Reproduction Update, and edited them all simultaneously for a number of years, eventually casting it off and setting up his own journal, which was one of the first online journals, Reproductive Biomedicine Online. He was a publishing entrepreneur in those days. He was a hobby farmer. This is his farm. And he still maintained contacts with his farming friends in Yorkshire, of giving them the prize for the best sheep. And he was a family man. I love this picture of him washing dishes in the home. He wasn't a man who would be self-aggrandizing. He could speak with anyone, and many of us have benefited from his informal conversations. And finally, I discovered in my research that he was a tree man. He planted thousands of trees. I didn't know about this. And I'd like to call him an environmentalist, and I don't know why he was planting all these trees, except that it was another aspect of the mystery of the man. There's a mystery about all of us, of course, but this man is still, for me, a sphinx, as well as a scientist. So, thank you for your attention. Without shame, I'd like to tell you that I've written the biography of this man in all of his shades, and I'm giving the royalties to Charities for Research and Clinical Treatment as my thanks to him and to the field for my good luck to be here and with you all today. Thank you.
Thank you, Roger. It really is a very, very moving, and I think only you who know him for so long and been working with him, and that you can really give a lecture like this, and we are really privileged to have you here. Thank you very much. And now we'll go to the next session, and I would like to invite the chairs, Ron Holmberg and Helen Picton.
Before we start this session, I must comment on that lecture, which I thought was an amazing tribute to Bob. So well done, Roger. I must admit, I had 3 good connections with Bob Edwards. 1, we were both born in the same place. 2, we have exactly the same accent in English. And 3, we both supported Leeds United, which was Bob's only failure in life. I'll hand over to Helen to introduce the first speaker.
It's a very difficult act to follow, I'm afraid. So, moving on to the next phase in the programme, we now have, sorry, we'll just gather our thoughts. We're looking at implantation, uterine receptivity, clinical and experimental findings. So welcome to the next session. Our first speaker is from Spain, Xavier Santamaria, and he's going to give us a presentation on the signal of the endometrium, which is increasingly becoming research focused in our activities and has been very much underrepresented in our research findings over many years. So very much looking forward to hearing your update on the endometrium and the research that's going on in your field.
Thank you, Mr. and Mrs. Chairman. Thanks for the introduction. Thanks also the organizing committee for this splendid meeting in this nice area and after this moving lecture that Dr. Gosden just gave previously. So I'm going to go to more, I'm going to talk about the endometrial receptivity. As first of all, disclosure that I'm director of the Asherman projects at Genomics. And actually, after we realized how difficult it was to perform the IVF, the truth is that live birth rates, despite the tremendous efforts and despite tremendous research, the live birth rates even range between 25 to up to 30% per initiated cycle. So IVF still is not a very efficient process. Mostly the most fundamental reason why this process doesn't succeed is because despite transferring competent embryos, most of these embryos do not attach, as we can see in this study from the Dutch team.